In the last video, we talked about the concept of work and how to calculate it under different conditions. Work is the tangible effect of a force. Whenever a force pushes an object over a distance, work is done on that object. In this video, we will introduce the related concept of energy and how it is calculated. There are two different ways of thinking of energy. We will discuss one approach to understanding energy in this video and the other in the next video. You're welcome to understand it in whichever way makes most sense to you. To begin, let's consider this animation. Here, we see the red block collide with the blue block. The two of them stick and then move together. Now, to get the blue block moving from rest, the red block had to exert a force on it. Indeed, we see the red block pushing the blue block over a distance. That means the red block did work on the blue block. This brings us to one definition of energy. We say that an object has energy if it has the ability to do work on another object. Energy is the ability to do work. There are several kinds of energy. In the example we just saw, the reason that the red block could do work on the blue block is that the red block was moving. Any moving object has the ability to do work on another object. We could say a moving object has a quantity of energy by virtue of the fact that it is moving. This type of energy is called kinetic energy, energy due to motion. I won't go through the full derivation, but at the bottom of the screen you can see the formula for kinetic energy. The kinetic energy of an object equals 1/2 its mass times the velocity of that object squared. Notice that velocity is a vector, but by squaring it, we are taking its dot product with itself, which turns it into a scalar. Just like work, kinetic energy is a scalar. Notice also that mass is always positive, and velocity squared is also always positive. Since kinetic energy is the product of these two positive quantities, it must also be positive. Kinetic energy can never be negative. An object doesn't have to move in order to have energy. In this animation, the blue ball is initially suspended from a height. It is released and then falls on the seesaw, which then launches the block. Now, the seesaw had to push the block over a distance, thus doing work on the block. The seesaw could do that because it, in turn, was pushed by the blue ball, and the blue ball was initially elevated. That elevation is important, so let's analyze that in greater detail. When the ball is elevated, it is in an unstable position. It has to be held in place because if it is released, it will start moving. Because of that unstable, elevated position, the ball has energy, which can be used to perform work on the block. We say that the ball has potential energy. Potential energy is the energy of an object in an unstable position. The object can only be in such a position if it is held there. If it were released, it would start moving. An elevated object is in an unstable position. It would fall due to gravity if released. As such, we say it has gravitational potential energy. Again, I won't cover the full derivation, but the equation for gravitational potential energy is at the bottom of the screen. Gravitational potential energy equals the mass of the elevated object multiplied by gravitational acceleration multiplied by the height of the object above the origin. On Earth, gravitational acceleration is the familiar 9.81 meters per second squared, except that this number is always treated as positive in this calculation. The height is always relative to the origin, but since the location of the origin is arbitrary, it's possible for the object to be below the origin. this would lead to a negative height and, in turn, a negative potential energy due to gravity. A negative PEG is completely legal. Gravitational potential energy, unlike kinetic energy, is allowed to be negative. Now, there are other types of potential energy besides the gravitational potential energy, and that's because there are other ways that things can be unstable besides being elevated. Here is a compressed spring that will press a platform outward when the latch is released. A spring that is either compressed or elongated is another example of an unstable system. So a spring is another source of potential energy. The potential energy of a spring is half its spring constant multiplied by the displacement squared, whether that displacement is a compression or an elongation. Because the displacement squared is always positive and the spring constant is also always positive, the potential energy of a spring is always positive. In this video, we introduced the idea of energy. One way of understanding energy is the ability of an object to do work. We also introduced kinetic energy, the energy of motion, and potential energy, energy due to an unstable position. There are two types of potential energy we will explore: gravitational potential energy and spring potential energy. In the next video, we'll explore how to use these equations in combination and how this combination leads to another way of understanding energy.